Hey everybody, sorry I'm not there today, but we're going to recap what's happening in your two worksheets and hopefully get you guys off and going in the right direction. So let's jump right into it here. We started off with this one. I want to explain it maybe a little bit clearer than I did the last time. So we've talked about, and I'll move this off to the side here so we can actually see what we're working on, but we've talked about two different quantities of motion. We talked about our scalar and our vectors. So from the first video we did yesterday, we know that scalars are magnitude only, size and amount. We do not have direction on those guys. So as a result, we don't have arrows above any of our symbols. So for example, we've got distance, which is the length of a path between 2 points or locations. That's marked with just the delta D. Okay. V and velocity or speed is marked as V or VAV. That's speed, no direction attached. T is time, M is mass or grams. But when we get into vectors, we know that our vectors have both magnitude and direction, and that's what we're going to deal with today. Anytime we have a direction attached to it, our symbols get a little arrow above it, just like that there. Okay, so displacement, okay, would be a vector quality. So we put the little line above. Now, obviously, it was hard to do when we made these things, but that is the straight line distance from one point to another. So remember, we said if someone started here and worked all the way over here and ended up here, all of this part here would be the distance that it traveled, but the line from one spot to another, as the bird flies or as the crow flies, that is our displacement, and it gets a direction as well. So we need to have that direction. So any of those symbols, we'd have velocity with a little arrow above, the average velocity, acceleration, and the average acceleration both get the little arrow up above. All right. So everything that we're going to do on this page for the most part deals with these questions around distance, displacement, and position. All right. So our position is a specific point on the map. So you can use a number line. You can use a XY grid. We'll try both of those today. All right. And remember, it has a direction attached to it. So if the position is 5 meters east, we can give that a direction. The distance, or delta D, is the path taken to get from one position or another to another. And so that could be this whole roundabout way. And so distance is often greater than the displacement, because the displacement, again, is from one point to another. The distance could be all the way over here as they go to that second point. All right. So then our displacement, and remember, we mark it with a little arrow above because it's got a vector quantity, so it's magnitude and direction. Displacement is the change in position. So to do these questions, you are going to need two equations. The first is our displacement equation. All right. So our displacement equation is this: the change in displacement, so the little arrow at the top, is the final position minus the initial position. And we try and measure these in meters. All right. So that's formula number one, is that guy there. Our total displacement, all right, our total displacement is the change in displacement for the first one and our change in displacement for the second one. So we'll show how this looks. So first question says, find the displacement vector from position A to position B if position A is positive 3.5 centimeters and position B is positive 5.7. So we're going from position A to position B. So anytime we do these, what we're going to do is we're going to draw a number line. Let's draw a number line in a pen, not a highlighter. So we're going to draw a number line across our sheet, something like this, okay? And so here's what we're going to do. We're going to find 0 point here. I'm going to put it over here because we don't have anything going into the negatives here. We start at 1, 2, 3, 4, 5, 6, 7. That's more than enough there. So we're going to start at 3.5 centimeters. So 1, 2, 3.5 centimeters. This is going to be our position A. So position A, it gets a little vector sign over top of it because we've got directions, is at a positive 3.5 centimeters. Okay, then we keep going. We count 4, 5, 6. That's all we really need. We're at 5.7, so somewhere right here. Okay, somewhere right here, we have our position B, and that comes out as a positive 5.7. So what this is asking is it wants us to find the displacement vector as it goes from position A to position B. So we can see if we're going from A to B, we're going to travel that way, positive, from 3.5 to 5.7. So we go back up to our equation here, and we're looking for our displacement. So displacement is equal to the final minus the initial. So we've got here our final, so displacement is equal to our position final, D2 you could call that, which is what we've got here, or let's call it by our letters here. So we've got position B minus position A, which is the same as saying 5.7 centimeters minus, and that's a positive 3.5 centimeters. When we punch that into our calculator, we get 2.2 centimeters, and that's a positive one. So we know that we are traveling positive on our number line. So in this case, from left to right, 2.2 centimeters. So right there, that's our answer. All right. So we used our displacement vector and we used our displacement equation up here to solve for it. In this guy, it says we're going to find the displacement vector from position X to position Y if position X is 6.9 meters east and position Y is 8.2 meters west. So again, we'll draw our number line. Here's our number line here. Okay, this time we're going to label this side east and this side west. So we know that we're going to have a 0 here in the middle, okay? And we're going 1, 2, 3, 4, 5, 6, 7, somewhere in there, okay? So at 6.9, that's where our position X is going to be. And that one is equal to 6.9. Our position Y is going to be west of there. And position Y is 8.2 meters west. So we're going to go west, and because we're going this way on our number line, we're going to assign it a negative number. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're at 8.2, so somewhere right around here. So this is our position Y, and that one gets a value of negative 8.2 centimeters. And so what it's asking, meters on both of those. And so what it's asking is, what is the displacement vector to go from X all the way down to Y? And so what we're going to do here is we are going to start with, I just got a notification this is going to run out, so we're going to pause this and we're going to continue this in another video here.